Well, hello and welcome. Happy Pi Day, everybody. Hey, in this video, we're going to talk about a couple things about pi, some stuff you probably know, some stuff that might surprise you, and then we're going to tackle this problem right here. We're going to find the area of that circle. Now, pi, of course, is one of my favorite desserts. Mine is blueberry. That's my very favorite. What's yours? Let me know in the comment what you think yours is. Now let's get serious. Let's talk about the number pi. The number pi, it is a transcendental number. That means, basically, that it is not a root or a solution to a non-zero polynomial number. Now, that might make you mad because that's kind of complicated. Well, don't worry. Pi is also irrational. See what I did there? Now, pi itself is just a number, but we use the Greek letter pi, which is right here, to represent the number, and the number comes up all over the place. Archaeologists find it. It's kind of strange. Do you know what this and pi have to do with one another? Well, I'll explain. All right, so if you have found a whole bunch of fence posts, and this is kind of how it works, archaeologists find holes or fence posts, and they're kind of a strange distance apart. Like, they're a little confused as to what was used to measure that kind of a distance. Well, if you take the distance between each of them and you divide by pi, you find out that the diameter of the wheel that was used to haul the cart, which had all the materials, well, it would be 0.6 meters in this case. Now, the reason that works is because on a wheel there's a mark you can put, and as it rotates, when it hits a certain spot, you just stop, make another hole. So, for example, by the way, I did hire Pixar to do this fancy animation. If you had a cart and your cart had all kinds of posts in it, and you're going to build a fence, well, you put your first post in when the mark on the cart is where it should be, and then you move the cart along. When it rotates and hits the same spot again, you dig a hole and put another fence post, and one more time, and there you go. So each of these distances will be some number times pi, and that some number turns out to be the diameter of the wheel. So that's how archaeologists stumble across the value of pi quite frequently. Kind of cool. Now, what is a wheel? Well, of course, it's a circle. But what is a circle? Well, if you start with a dot, a single point, and you have another point, some distance, and you have an infinite collection of points, all the same exact distance from that center point, like we have here, well, then what you have is a circle. That's pretty cool. Maybe my favorite shape. So, of course, that distance is called the radius, and the distance around the outside all the way around is called the circumference. Across this, from one side to the other through the center is called the diameter, and where pi comes from is, as you probably already know, you take the circumference, divide by the diameter. For any circle, you get pi. Or you could take the circumference, divide by the radius, and you get 2 pi because, well, the radius times 2 is the diameter. Now, if we take that distance of the radius and start over here and we fold it across, that is called 1 radian. And if we do it again, you get another radian there, and it almost makes a complete half of a circle. But there's a little leftover space right there. Turns out that leftover space is 0.141592653. I'll stop. You get the idea, right? So 1 radian, 2 radian, 3 radians almost make a half of a circle. In fact, it's 6 plus a little extra. It's 2 pi times the radius is the circumference. So if you had a circle and you wanted to know how long is it around the outside, you take the radius, multiply times 2 pi. It'd be 2 pi radians. It's the distance around the outside. That's pretty cool. Anyway, let's talk about our problem. So we've got this red circle inside this triangle. This turns out to be everybody's favorite Pythagorean triple, a 3, 4, 5. Now, this video's been done a bunch of times, or this problem's been done a bunch of times. I just think it's super cool, and I thought it'd be a good one to do on Pi Day. So let's go ahead and dive into it. So let's say our formula, well, I only know our formula for the area of a circle is pi r squared, so we have to figure out what is the radius. All right, well, the radius would be from there to there. We can call that r, and this would also be the radius from here to here. Now, these sides are tangent to the circles inscribed inside the triangle, right? So we know that they make right angles, and it's all beautiful and wonderful. we have one more radius right there. So let's talk about this radius distance right there. That is the same as over here, which gives us a side of r and then 3 minus r. So if you add those two together over here, you get a distance of 3, which is exactly, well, what we need, right? All right, so now let's see the other side right here. If we take that side and we drop it down, well, then we can see that that's also r, which gives us that bottom side is r and 4 minus r. All right, so now let's take a look at these sides right here. This distance from that point to the end, and once again, over here from this distance to the end, this actually is a kite from the center of the circle. So I know both of those sides are equal. There's another way to know they're equal. If you've ever taken a geometry class where you do lots of constructions, you probably did this one. Those two tangent lines, because they converge here, they are congruent. That's pretty cool. So that means that that distance is 4 minus r. Now we have the same deal happen at the top over here. We have that distance over there is going to be exactly the same as this distance right here, so that part is 3 minus r. So I know that hypotenuse is equal to 5, but the blue plus the green parts also equal 5. So 3 minus r plus 4 minus r equal 5. Now that's pretty cool. That's an equation we can solve. Let's go ahead and dive into that, shall we? So let's go ahead and do a little rearrangement, right? 3 plus 4 is 7. Negative r minus r is negative 2r. Let's go ahead and subtract 7 from both sides. We get 0 on the left, negative 2 on the right. Clean this up. We're going to go ahead and divide both sides by negative 2. And as you can see, r is going to be equal to good old-fashioned number 1. Let's plug in our value. 1 squared is 1. 1 times pi is pi. So the area of the circle is pi. That's pretty cool. Happy Pi Day, everybody. Hope you enjoyed this video. If you did, give me a comment, likes, thumbs up. I hope to see you again in the future. I hope to hear from you, and have a good day.